Good evening, students. I'll start with the class. In the previous class, we had seen the kinematic equations. The three of them were V was U plus AT, or the second one could be in terms of displacement. Suppose you want to know UT plus half AT square. The whole set you have to know. Then V square will be equal to U square plus 2A. Where V is the final velocity, U is the initial velocity, A is acceleration, T is time, and S is for distance or displacement. One problem we had solved, one more similar one will solve. The question is, the car is moving on a straight road at a speed of 108 km per hour and brought to rest within a distance of 60 meters. What is the retardation of the car and how long does it take to stop the car? Now, first thing I told you, always look out for the units of the speed and all given to you. First of all, you know that there are two cases I told you, when the car starts from the rest and then accelerates, or it is moving and then stops and brought back to rest. So this is the second case where it is moving already. So here it is like somewhere at this point it is there, it is at 100 kilometers per hour, and then it is coming to a stop. So that will be obviously at the stop it will be 0. So your initial velocity will be always, so there are only two velocities here. One always will be initial, the other one will be final. So obviously this becomes the initial now. Final is when the car will stop. So that would be 0. And how much distance has been told? 60 meters. Now that U is given to you as kilometers per hour. Always convert it first into meters per second. So that's a fixed, this I told you. Kilometer means always 1000 and hours means always 60 into 60. So that could be 3600 if you are writing, or you can keep it as 60 into 60 also, no problem. And then calculate. And then 18 threes are, no? Answer you will get as 30 meters per second. If you take 108 and calculate, the entire problem will be wrong. So U value is 30 meters per second. Now what all I have to calculate? U I know 30 meters per second. V I know is 0. A I have to find out. T also I have to find out. S is given to me as 60 meters. So whenever you know distance, U and V, we have to always use the last one because we know V over here, we know U also, we know S also. Here what is happening, we don't know T also, we don't know A also. Any equation with two unknowns we cannot solve. So this is the only equation right now where you know all the three things. The fourth one you have to find. So use that formula and then calculate your acceleration. Since it is retardation, your answer should come in terms of negative. Just check. Always the answer will be negative. If you are getting positive means something is gone wrong. This is 0, 30 square. This is 60. 30 square. You don't have to sit and calculate so much. Whenever there is a 0, it's very simple. 3 square will be always 9 and 0 square means always 2 times. That will be 900. And 2 into 6 will always give me 12 and just you have to add a 0 in front. This will be 128. Or even if you don't want to do this now, I told you like last time, best option is this, anyways take it this side. So this will become minus 30 square. Keep it like this one. 2 into 60. So minus 30 can be written as this minus is outside and this 30 square is 30 into 30. And this will come down. So like this if you keep, it's become easy to calculate. So minus 15 by 2, which is nothing but 7.5 meters per second square. This is the unit for acceleration. If you write wrong unit, again you will lose marks. Now I got a first part. So the car is retarding at 7.5 meters per second square. Now they asked you the time. So now you can use either the first equation or the second equation, whichever you want, and then calculate. So V is equal to U plus AT. The first one I'll use to find a time. V is 0, U is given as 30. Now here also what you can do, always use the fraction straight away instead of using decimal point. 30 you take on the other side, it will become minus 30. Now this 2 will go up, minus 15 will come down. And time you can never get negative, you know that. If you're getting time as negative, something has gone wrong. So 4 seconds. So time is 4 seconds. Any doubts in this problem, you can ask. The next question. starting from rest, the car accelerates with 3 meter per second square for 5 seconds, and then moves with uniform acceleration. For uniform velocity. What is the distance traveled by the car in 7 seconds? Starting from one rest, one car is accelerating first for 5 seconds. And then from after 5 seconds, it is moving with the uniform velocity. And what is the distance covered in this? So we'll try to understand what it's trying to say. There is one car which is starting from rest. So obviously you will be 0. This is starting from rest. And then it is accelerating for 5 seconds. Consider this time is for 5 seconds. How much it is going up to? 3 meter per second square. And then after this point, it is not this. Okay, after this point, what is happening? It is moving with uniform velocity. Can anyone tell me? Uniform velocity means I'm not changing the speed at all. So what will be my acceleration? Can anyone tell me what is the acceleration for uniform or constant velocity?
0.
Yes, very good. So for this part, up to 2 seconds, whatever is that part. Oh, okay, wait. After that 2 seconds, I'll tell you how we'll get. So after this, it is going at 0 acceleration. Your acceleration is 3 meter per second square. So what have they asked? What is the distance traveled by the car in 7 seconds? Distance is how much for this particular time. So for the first 5 seconds, acceleration is 3 meter per second square. After that, it is uniform velocity, means for the next. So you know that definitely this time will be how much? 7 minus 5. Total 7 this it is covering. So this 5. So this for the 2 seconds, we know that your acceleration is 0. How we get? Total 7 minus 5, that will be 2. We'll start calculating for the first part. In parts, we'll have to calculate. So for the first part, u is 0. V we don't know at what point. Okay. After this, just before this, we don't know at what speed uniform velocity it is going. So V we don't know. Acceleration we know now is 3 meter per second square. Here we don't have to do any round this conversion. Everything is in terms of meter. Time we know from here to here is 5 seconds. So we'll calculate the velocity. Distance also we don't know. Time is 5 seconds. Don't get confused with this S. Huh? This S is for second. and this S is for distance, how much meters. So distance also we don't know how much it has traveled. So only this much data we know for the first half. So obviously you can use the first formula, V is equal to U plus AT. U we know is 0, acceleration is 3, and time is 5. So V we got. So at this point, V is how much? 5 3s are 15 meters per second. So from here to here, it remains constant. So what happens? It started with 0 speed. Okay, it accelerated, and then at this point, it was how much? 15 meters per second when it reached at this point after 5 seconds. Then it is not changing. Then throughout till wherever it does for the next 2 seconds, velocity will remain as 15 meter per second square. It will not reduce also, it will not increase also, going at a constant speed. So now we'll check over here how much distance it is covering. For this first part, we'll calculate the distance. Okay, so this is for part A we are calculating. So we'll check distance from here to here will be how much. If you want, you can write letters also, A, B, and C. So we'll find distance AB first. Why? We have to find a total distance. So this distance plus this distance you need to find. From A to B, any distance formula you use, V square is equal to U square plus 2AS you can use. Now just now we got what is V square, that is 15 square. U is anyway 0. Acceleration is 3, and distance we have to calculate. So 15 into 15 you write 2 times because it is square, and this will come down here. You can write it as 6 also. And then calculate. So it will give you 75 by 2. So that is 37.5 meters. So your distance is from here to here, it is A to B is 37.5 meters. Now I want to know what is the distance from B to C. I want to calculate distance B to C. So what all data I know from B to C? V is 15 only because it remains constant. That will be U here. See. This is a starting point now from B to C. So U will be 15. Then acceleration is 0. Time is for 2 seconds. We don't know what is the final velocity. We have not been told that it is stopping at C. We just said it is going uniform velocity. We cannot write V as 0. So only this data we know. So which formula you can use where we know U, A, and T? Can anyone tell me first, second, or third?
First one.
First one, if you find what we need to find. Distance. So in the first one is the distance. S is not there, no? Third one, if you use, we don't know what is V. You know only U. So which is one you can use? The second formula. You need to know what exactly you want to find. You want to find a distance. Definitely try to use the formula which doesn't have V in it, because we don't know what is the final velocity. You know what is the initial velocity at point B, that is 15. So this S we have to find. This is 15. Time is for 2 seconds. And this whole thing will be 0. So this will give you 30 meters. This whole part will be 0. And now total distance covered by the car will be 37.5 plus 30. And one was not understood. Okay, next one. A car travels with uniform velocity 72 kilometers per hour. Driver applies the brake and comes to rest. With uniform retardation in 10 seconds. First, find retardation. Second, velocity of the car after 3 seconds. Third one, distance traveled by the car after brakes are applied. These are these brakes. Driver applies the brake and comes to the rest with an uniform retardation in 10 seconds. The first one is normal retardation. So starting with first, it is initial like this, and then at some point it will finally stop. It was at this point it was 72 kilometers per hour, and then at some point it is applying brake, and this total time is 10 seconds. So as per that, anyways, V will be 0 because they are told it is stopping, comes to rest. U is 72 kilometers per hour. So calculate, convert this because this is kilometers per hour. So this will be 20 meter per second. So U is 20 meter per second. V is 0. Time is 10 seconds. So calculate your retardation. First one is simple, straight away. So what all data is there for the first one? Retardation we have to calculate. U is 20 meter per second. V is 0. Then time is 10 seconds. What is your acceleration? Now we cannot use the last formula. Now distance is not given. Check for that formula which doesn't have distance in it, because we don't know what is the distance also. So the only first formula we can use, because we know the time, we know U, we know V. Okay, here we can, right now we will not take this part for this as 0. This 0 is here. So we'll take this as A, we'll take this as B. Retard, till here it is retarding. And after that it remains uniform. So we don't know before applying the brake at what velocity it is. So here we'll take normal V only. So we'll calculate exactly at while applying the brake, what was this velocity. For the final, after stopping it is 0, but I just want to know what is the retardation. So all this will be unknown. No, then take it as 0. Huh? Full retardation it is. I thought A was given to me. Sorry. I thought this A is given like previous problem. Correct, it was. V is 0. So V is equal to U plus 80. Calculate. Full retardation it is. This brake part is later. Distance traveled by the car after the brakes are applied. This is full retardation. So V is anyway 0. U will be 20. A we have to calculate, and time is 10. So just tell me what retardation you are getting. Calculate and tell.
-10.
Minus 10 you got? Check properly again.
-2.
Yes. So you must have made a mistake. You did. First minus 20 will go anyway that side. This is multiplication. So don't take this side and make it this. So it is multiplication, means it will always go under division. By mistake you must have added or subtracted. So just write here minus 20 upon 10, which is 8. So this is your first part, that is a retardation. Now your second part says what is the velocity of the car after 3 seconds. V after 3 seconds. means somewhere it had started. After 3 seconds, how much is the velocity at this point? So it's very simple. Just look that we don't know what is the velocity. So velocity will be question mark here. Time is 3 seconds. U is anyway same. The starting point will anyways remain same. 20 meters per second. Just now you got the acceleration. What is it accelerating with? This A is minus 2 meter per second square. Now use whichever of the formula is applicable, one of the three. First one is easy to use. A you know, T you know, U also use. Because you cannot use the second and the third one because we don't know the distance. Both third and the second have distance in it. So after 3 seconds means time is 3 seconds. We have to calculate what is the velocity after 3 seconds. So U will be 20. This is minus 2 and time is 3. Velocity is 14 meters per second. Third part, after the brakes were applied, what is the distance? So brakes applied means retardation, means the whatever acceleration is there, it will reduce. So brakes applied means the same retardation I have to use. A will be how much? Minus 2 meter per second square, which I already got here. Distance I have to find. How much is it? V anyways will be 0 till the last point we have to calculate. U will be how much we have got? 20 meters per second. Full time also we have. Everything we have now. V also is there. V is 0 till the last point. So you can use the second formula also and you can use the third formula also. Whichever one you want to use, you can use to find the distance. Just put all the data and calculate the distance. A we have got as minus 2. S we have to calculate. U is 20 meters. T is 10 seconds. And V is 0. This is 10 square. 2 and 2 will cancel. So that will give me 200. And this is minus 100. 100 meters. Don't forget to write the units. Huh? So this was normal on the straight line problem. Now we'll move on to the next types. This would be under motion under gravity. Suppose now you throw a stone up, okay, in the air. You just throw it up. Definitely, it will not go out of the earth. Okay, it will reach to at some point. So suppose if you are on the ground here, okay, and you're throwing it, you throw a stone upwards. So obviously, at some point, it will go based on with how much force you are putting or how much speed you are throwing it at. And obviously, after some point, it will stop and then it will fall back to the ground. And you know that why is it happening? Always there's a gravity of the earth which pulls it down. So that's why they don't remain in the air only. It comes back to the ground after a certain point. So what is going to happen when you throw the stone up, the speed, you'll be throwing it very high speed. But as it go upwards, what is going to happen? There's a negative gravity which is pulling it down. Okay, so this is called as the acceleration due to gravity. So this is why negative, because tries to pull the stone wants to go up, but it is trying to pull down. So it's a negative impact on the speed. So what will happen? The velocity will decrease as it goes on this. So tries to pull the stone down. So that's why it is negative. Now, it with certain initial velocity you are throwing. Okay, so you'll have some initial velocity. At this point, the stone will stop for a fraction of a second. So can anyone tell me what will be the velocity here when the stone will stop and then start falling back?
0.
Yes. So finally, what will happen? Somehow he will try to go upwards, and then his speed is becoming 0. That is why he cannot go any more further up. It's like he loses all his energy and then comes back. So here always this will be 0 at the maximum. And this part, this whole thing is called as a maximum height. Okay, sometimes they'll ask in the problem to calculate the maximum height. So it's nothing but from initial point till the last point where this stone stops, no, going upwards and then starts coming back. That is called as a maximum height. Also called as the distance covered by the stone. Okay, so this is the S. Suppose if you are throwing from the ground, it will be the distance covered by the stone to the maximum height. Now the time, total time covered by the stone. Remember, this is very important. Time taken to reach up is equal to time taken to reach down. Although practically you may think, while going it's against the gravity, it must be going slower, and while coming it's coming very fast, so time will be less. No. Okay, because there is air resistance also. Okay, there nothing much to know too much in detail. Then like later we'll be anyways seeing that. So the what you have to know now is the time taken to reach up will be same as time taken to reach down, irrespective of that. Okay, because finally, because of this own resistance also, at the end of the point, finally it will take the same time how much it took when took to reach up. So this is very important to know, because whenever they ask you if you calculate this time, no, it is always multiplied by 2, because it's the same time which will be needed to come down. Only this much you have to know. And then what signs to take while solving the problems. Suppose if you have a reference line, okay, all the distances, so I'm just putting the word S means for distance. If you don't still know, then write and keep. Distances upwards are always to be taken positive. Means what? If you are calculating the distance of the stone, like from here to here, while going up, then the distance has to be, displacement has to be taken as positive. Suppose if it is coming from up to down, the stone, from up to down, then S is to be taken negative. Okay, so upwards S is positive. So if I say the stone is coming from a 20 meters height, the stone is falling from 20 meters, you have to take it as minus 20 when it is coming down. If the ball, this ball is thrown upwards and going to 20 meters up from here to here, then you have to take this as positive. Same way for velocity also. This velocity is positive, here it is negative, downwards. Velocity while going up is positive, and while coming down it is negative. Same, now this acceleration due to gravity, G is acceleration due to gravity, it is negative downwards. This side also it is negative. Please remember this, very important. Because the direction of the gravity of the earth is not changing, whether the ball is going up or down, the earth is pulling towards downwards only. Okay, whether you throw the ball up, okay, or whether it is falling out from the height, the direction of the gravity is not changing. The earth's gravity is remaining same, so it is trying to anyways pull it down. That's why in both the cases you have to take acceleration due to gravity negative. This part you remember. G is to be taken negative. So now we'll start with the normal problems. Any concepts which are left this incomplete or something not understood, you'll understand now while calculating the time and the maximum height. A body is thrown vertically upwards with speed u. Find the time taken by it to reach maximum height. Second, calculate the maximum height. And the third one, time taken to reach final point. Now first one, we'll calculate the time taken to reach maximum height. So same formulas we have to use. CV is equal to U plus AT. S is the normal one, whichever you want to use. can use the v square. Okay. Now, what has been told? The ball has been thrown vertically upward. So I want to calculate what is the maximum height or maximum time also. Time taken by it to reach the maximum height. Maximum height will be s here now. The distance traveled by the stone from the, or the distance traveled by the body from this ground till the maximum point where it will become 0. S is a maximum height and the time taken will be t. Now over here, acceleration due to gravity, whichever a is there, no, you have to refer. Whenever body is been thrown vertically upwards, it's always taken to be g. Now g can be, it's a fixed thing, 9.8, or sometimes they take as 10 meter per second. If specified in the problem saying take 10 meter per second square, then you have to take as 10. Otherwise, if not mentioned, you have to take it as 9.8 meter per second square. Okay, this is when the values have been given to you. Right now, anyways, we'll calculate only in terms of formula point of view. We will not substitute here. So first, what we'll calculate is the time. So we'll use the first formula. Now v is 0. U will be some initial height only. We don't know. We have not been given the value. It's just that speed u. It starts with speed u and then it goes to 0. Now here acceleration will be minus g. We will not substitute as of now because no values we are calculating here. We only to understand what is the formula for time. And time is what we have to calculate. So u you take on the other side, it will be minus u. And then g you bring here. So this is the time taken by to reach the maximum height. So this is your first part. If values were given, you have to put values. Suppose if this was said 50 meters per second square, so this would have been 50. This would have been 10. If suppose you were asked to take 10, then you have to, it would become 50 upon 10 and then it would be 5 seconds. So this is a general formula. So any kind of number is being given, you just have to substitute like this and then calculate. Now let us calculate the height. Height means nothing but a distance. So we can use the last one. V square is equal to u square plus 2as. V is anyway 0. U we don't, U is given as U only. This is minus G. Acceleration due to gravity, I told you, irrespective whether the ball is upwards or coming downwards, take it as minus G only. And this is what the height. So I'm just taking it to be H, or you can keep it as S only, no problem. I want to calculate this distance. So this one will become minus U square. Minus U square upon minus 2G will be your answer. So minus minus will cancel. So this is your maximum height. So whenever you calculate maximum height, V is always 0. And the third part, time taken to reach final point. Final means back to the ground. final total time it means. To go upwards, how much I told you? Time to go upward plus time to go down to reach down. How much you needed to go up? U upon G. And I told you it's the same thing for this one also. If it's taking this time to go up, that same, both the times are equal. So therefore your total time will be 2 plus 2 times. So if you get one way time, you just have to multiply it by 2. You'll get the other way, the total time. Now, this is the question. The stone is dropped from a tower of height 20 meters. Find time taken to reach the ground. Second, speed just before hitting the ground. So there's a tower, suppose we are standing, and suppose the ball is here, or the stone has been here, exactly at this height, and it's been dropped. Now you have to understand, whenever it is been dropped, no, it's just like you're holding it in the hand and just releasing it. Okay, you're not pushing the ball. So what is going to happen? You're just releasing it. So it will start at 0. So whenever you have dropped, okay, it means always u is 0. And if said thrown, no, throwing means you are putting some force. So that will be, u will not be equal to 0. Then they will give is thrown at a speed of something. Thrown means you are putting some speed on that. But dropped means always you have to take your start. Now the ball stone is starting from here. So u will be 0. So initial velocity is 0. How much is the height? 20 meters. So that is nothing but your distance, or s. S is 20. So what all data you know? Get it right. Take acceleration due to gravity as 10 meters per second square. Just for simplification, we'll take it as 10. Other than 9, normally they give in the papers 10. If they don't mention, take it as 9.8. Now they will say only take G as this. They will not specify whether you have to take positive or negative one. That you have to know, that you have to take minus, irrespective whether they have given it as plus or minus. So you know that u is 0, s is 20, g is irrespective. I told you whether the ball is going up or coming down, g you have to take as minus 10. G always negative for this. What we have to calculate? Time taken. And then speed just before hitting the ground. Just before hitting means almost hitting the ground. Exactly at the ground, it will become again 0. So that we don't want. Okay, after touching the ground, the stone velocity will become 0. That we don't want just before hitting the ground. So V is how much? It's like calculating a final velocity almost before reaching the ground, which won't be 0 for sure. So we'll calculate it. So out of those 3 formulas, whichever you want, you can use. U is there, S is there, G is there, means A is there, and T we have to calculate. So first one we cannot use because we don't know what is V. We'll have to use the second one. Now, can anyone tell me whether distance taken is correct or not? S will be how much? Has anyone noticed? Yes. Yeah. S is equal to minus 20 because the ball is coming downwards. I told you, distances downward will always be negative. So take S as minus 20. So this, if you take plus 20, it will be wrong. U is 0. You have to calculate the time. This is minus 10. This will be minus 5. Minus 20 is equal to minus 20 upon minus 5 will be T. So T will be root of 4, which can be plus or minus 2. Time cannot be negative. So obviously it will be 2 only. So time is 2 seconds. Then we have to calculate your final velocity V. So now you can use the first formula because now you know what is the time taken. So this will be n with 0. Minus 10 we have to take. And T will be 2. So just before hitting the ground, it is minus 20 meters per second. So this is your velocity. Any doubts in this problem? You can ask. Next question. A ball is projected vertically upwards from a tower of height 20 meters at a speed of 5 meters per second. Find first one, maximum height reached by the ball Second, time taken when it passes from its mean position. A ball is projected vertically upward from a tower of height 20 meters at a speed of 5 meters per second. Find the maximum height reached by the ball and the time taken when it passes from its mean position. So if there's a tower, that tower is of 20 meters. Now, there's a person who's standing here again. What is going to happen? The ball from the height. So now it's like from this height, it's been thrown vertically upwards. You don't know where, how much exactly it is going to. Then it will stop here. Okay. And then it will definitely come back. At this point, anyways, it is v equals to 0. Now u, they have mentioned at a speed of 5 meters per second. So u is 5 meters per second. Okay, the ball is being thrown at 5 meters per second. So it will go up, it will reach 0 and then come down. What is the maximum height reached by the ball? So now whenever there's a maximum height like this, it's on the tower. So whenever they say maximum height, it is always with respect to the ground. Okay, so if this is the ground, so from here to here, they are expecting the maximum height. This is the maximum height. Okay, the maximum height till here. So what it will be? It's like whatever distance it is covered from here to here plus 20. So now let us see how much distance has this ball covered from this part to this. We'll calculate this S. So you know that u is 5 meters per second, v is 0. We don't know what is the time, but we know what is g. It's nothing but you can take, now if they have not mentioned, then take it as minus 9.8. And calculator, first before this, you have to calculate a distance. So which one you'll use? The third one. In terms of a, g you know, or a you know, v you know, u you. The first one and the second one equation has time in it. So we cannot use that because we don't know what is the time. So we'll use the third one. This is 0. This will be 5 square minus 9.8 into s. So this will be 25. If I bring this side, it will be minus 25. And then multiply 9.8 into 2. So that would give you minus 19.6. Minus 25 upon minus 19.6 will be your distance. calculate 25 divide by, you want to calculate normal y, so what it will be, point, if I'm removing this side, I have to shift a point here also, 1 point. So it will be 250 upon 196. 1 point this side, 1 point this side. And then you can calculate. It's 250 divided by 196. We'll get 1.27. I can consider 1.28 as a distance. This. Now I want to know what is the maximum height. So it will be 20 plus 1.28. So that's the maximum height reached by the ball. And then the second part, time taken when it passes from its mean position. Mean means back to its same thing. So this is the time. So this time and this time. Till here. Huh? So you know that here to here will be same as here to here. So where it started, where it ends at the same level, this time and this time will be same. And after that we are not bothered. They just want till the mean. This is called as the mean position. To calculate one time, then you will get the total time, 2 times. So for the second one, time we have to calculate. So v is equal to u plus at we can use. V is anyway 0, u is 5. This is minus 9.8, and time we have to calculate. So minus 5 upon 9.8. So again, point, decimal point I want to remove. So this will become 50 by 98. Then definitely this part I should know. 50 by 98. 98 is not going in this. So this will be anyway 0. Then point. Then 1 0 will be added. And then you have to calculate. So it would be somewhere around 0.51. And then total time will be from here to here is 0.51. And then same time here. Okay, so add both. So it will be 1.02. Next one. For the same thing, actually you can calculate. One more part you can add. Otherwise it will be writing the same problem all over again. Same question. After that, you just add on. Third part, you can say calculate the speed of the ball just before hitting the ground. This is the third part. Just before hitting the ground means somewhere here. So V is how much? So from here to here we have to calculate. We are not bothered about this V now. This is your U and this is your V now. Rest all data will remain the same. So for here to here, you know that U is anyways 5 meter per second. Then V we have to calculate. A is anyways minus 9.8 or G whichever it is. And then distance, height. So height, how much we had got in the previous problem? Height of the tower plus that, how much we had got? Can anyone tell me?
21.28.
21.28.
28.
Okay. So you can use this and then calculate. V square is equal to U square plus 2AS and then substitute the values. So V square will be pi square this less, just check again. 22 it was, no? Or 21 something.
21.
21.28.
So we have to take it as minus now. Because it is coming downwards. And then calculate. So this will give me 25. And then it should give me a positive value. 2 into 9.8 into 21.28. So around 417. So 417 plus 25. 442. And then the root of 442. Just ask your teachers whether they are expecting this time using log tables they'll be giving or not. If they are allowing you all to use log tables, then I'll teach you how to calculate the root using log tables, or else the normal long method I'll teach. Just first find out from your college, okay? So as of now, I'll just do it with the calculator. So that will be 21 0.02. Sometimes they give the logbook, and you can always find using logbook also. Now since it is online, so I don't know how they are expecting you to calculate. So just tell me. Whichever way they are teaching, I'll explain. So that will be the velocity. Just put it as meters per second. Next one. A ball is thrown upwards at a speed of 28 meters per second. Find the speed of the ball 1 second before reaching maximum height. A ball is thrown upwards at a speed of, so what is it trying to say is it will reach somewhere here. We'll start at 28 meters per second. So you know that finally it will be 0. Now we have to check 1 second before reaching the maximum height. So which is a maximum height? This is a maximum height. First we'll have to check how much time it is taking. Is the time has been told? How much time is it needing from here to the final point? No, we don't know. Okay, so we'll have to first check how much time has been taken to reach there. Then only we'll come to know where it will be there 1 second before the time. So we'll check whether it is taking 3 seconds, 5 seconds to reach here. So if it is taking 5 seconds to reach here, then we have to calculate what is the velocity at 1 second before reaching means at 4th second. So we'll check how much time it is taking. So u has been given to me as 28. V is given as 1, or this 0. This time will be needed later on. A anyways is minus, just for calculation you take now as G as minus 10 meter per second square. Instead of 9.8 we'll take it as 10. Now calculate the time taken to reach the maximum height. So obviously you know that V is equal to U plus 80. This is 0, this is 28, and we don't know the time. If not given, no, you can put it as 9.8 also, no issues. So this will be minus 28. This will be 2.8 seconds it is taking to reach here. Total time taken is 2.8 seconds. Now from here to here, suppose it is 1 second. What has been asked? Find the speed of the ball which is before reaching the maximum height, 1 second before reaching. So here I want to check what is my velocity. Can anyone tell me what will be the time taken to reach here now? Whole time is 2.8 and this is 1 second less. How much will be the time 1 second less than 2.8? Full time is 2.8. I just want to know 1 second before that. So what will be the time over here? 1 second less than 2.8 is how much?
1.8.
1.8, yes. Because this full thing minus this. So this is 2.8 minus 1. So this will be, so I want to know at 1.8 second what is my velocity. So the time is speed at 1 second less means at t is equal to 2.8 minus 1, which is at 1.8 second we have to calculate. So use the same formula. Now v is how much? We don't know. We have to calculate. U anyways is 28. And this will be 1.8. So this is 28 and this is 80. So 2 meters per second. So just before reaching 0 at 1 second before that, the speed was 2 meters per second. At 10, sorry, 10 meters per second. So that's the answer. The time left is okay. Just some 2-3 problems I solved based on the relative velocity. The question papers I will be solving after all the 3 chapters. Now only have to hurry up because the CTN college exams are starting early compared to all other colleges. So I'll basic whatever the problems needed for their college point of view I'm doing now. The means anything call specific, especially Pope John, no, they get difficult papers slightly. Otherwise, normal like simple problems you'll get other colleges. So from that point of view, anyways, I'm doing this problem. Now, anything extra which comes specifically in your papers, I'll be doing after the 3 chapters. So anything that has been missed now, we'll be revising it throughout. Only thing that college which is starting exams early might miss that. But you'll have to stick to your notebook only. Whatever I've covered, the simple ones only there. On this question, based on these are on relative velocities. For relative velocities, the first one is a car A moves along a road with a speed of 40 meters from west to east, while another car B moves on other road with a speed of 50 meters per second from east to west. Both the roads are parallel to west-east direction. Calculate relative speed of car B with respect to car A. A car A is moving along the road with a speed of 40 meters per second from west to east. This is the west direction. Obviously, as per this is the east direction. This is okay. While another car moves on another road which is parallel to it, okay, from that is moving it. Both roads are parallel to the east-west direction, means they are parallel. Calculate the relative speed of the car B with respect to A. B with respect to A we have to calculate. The simple problems, just 2 steps. Anybody remembers what is VBA formula? V with respect to
VBG
yes minus VB with respect to ground. What is the this VBG with respect to ground? What is the velocity of the car with respect to ground of car B?
50
Can anyone,
kilometers to 50 meters per second.
can anyone tell me something is wrong here? And this is 40. Something is wrong. Can anyone else notice?
Miss, there should be VAG.
Okay, not oh sorry. Okay, other than that, the substitutions. Velocity of car, I sure it's only 50.
Minus 50.
Yes, for relative, please be careful. The directions, otherwise all these directions would not matter. Why would they specify west to east to west? So this is going in the positive direction and this is going in the negative x-axis direction. Okay, so that's why it has to be taken negative and this is positive and this sign is anyways minus because of the formula. So it is 90 meters minus 90 meters per second. So don't make that mistake. Please be careful of the direction. Next one. On a long horizontal moving belt, a child runs to and fro with a speed of 9 km per hour. With respect to the belt, this is with respect to between his father and mother, located 50 meters apart on the moving belt. the belt moves with a speed of 3 kilometers per hour. For an observer, on a stationary platform, outside, what will be the speed of the child running in the direction of the motion of the belt. Second one, speed of the child running opposite to the direction of the motion of the belt. This is a question. Okay. Now what they're trying to say is there's a long horizontal belt and then there's a father, there's a mother. This is 50 meters. And there's a child which is trying to run. One time it goes this side, sometimes it comes back also. To and fro means going in front. Once it reaches the mother, it will come back to the father and this way and that, both the directions. Okay. So whichever way is coming, while going also it goes at its speed that is constant, 9 kilometer per hour. And while coming back also 9 kilometer per hour. Now this belt is moving in just one direction, that is fixed. This is the belt. And from here there is one observer. So let that be O. Now he is observing the child who is running on the belt. So I'll use the letters. C is for child. O for observer. And B for belt. Your father and mother will not come into picture. That is simply given just to know that it's just coming and going back in terms of word problem. Now you have to observe that is distance is in terms of meters. But what is going to happen is that velocity which has been given, that is given in terms of kilometers per hour. We will have to convert those. So first we'll just write whatever it is, all the velocities with respect to this. So now the belt obviously is going with respect to ground. With respect to ground is 3 kilometers per hour. So you have to convert this. So if you calculate this, you will get it as 0.83 meter per second. Then V, what has been given? Now this child, the child is not at rest on the belt. If the child was at fixed position of the belt, he would take up this speed. So this would have been simple. Child with respect to ground would have been 3 kilometers. But in the previous problems, we have seen that whenever it is not fixed, whenever it is not moving, it is always with respect to the belt. So with respect to the belt, okay, child with respect to belt is 9 kilometers per hour. If it was fixed, then straight away. If you ask what is the this relative this of the father, definitely it is 3 kilometers because it's fixed, it's not moving. Same way of the mother is also 3 kilometers per hour. But of the child, he himself is having his own speed, so that is with reference to the belt. So we have to convert this also. Then it will give you 2.5 meters per second. Now what has been asked for the first part? When first part is when he's going this side, and second part when he's coming back. The first part is when they are both in the same direction. So velocity of the child with respect to observer. So who is observing? Observer is always second, I told you. VCO we have to calculate. So that will be nothing but with respect to ground. Observer is not moving, he's stationary. Stationary means at rest, fixed. Now this child with respect to ground, we don't know yet. We have to calculate. So keep it that much only. Can anyone tell me what is the velocity of the observer with respect to ground if he's fixed? He's outside the belt, he's not standing on the belt. What is the velocity?
0.
How much?
0.
Yes, 0. Okay. Now we let us calculate this fellow and then substitute here. So we know that VCB with respect to belt will be VCG minus VBG. So with this part we have to calculate. Now child with respect to belt is 9 kilometers. Sorry, now we cannot take 9, this part 2.5. And of the belt with respect to ground is 0.83. So 2.5 plus 0.83. So that will be 3.33. Just to confirm your value, last class I told you, whenever you want to calculate the velocity of the child with respect to ground, you just see the direction. If they both are going in the same direction, no, these values will always get added. Okay, this child's velocity and belt's velocity will always get added if they are both going in the same direction. If they are both going in the same direction, so automatically it will get added. So 0.8 plus 2.5 will give me 3.3. In the second case, when it's going in the opposite direction of the belt, it will always get minused. So just to like, this is a shortcut method to check. Add both the velocities in. So that now put it here. So VCO with the observer it is 3.33 minus 0. So this is a first answer. Now in the second case, we have to take this. This part will anyways remain same. While calculating this part, now velocity of the child with respect to belt now is going in the opposite direction of this. So you'll have to take it as minus 2.5. Ulta direction is going in the second case when he's coming back. While going in the first case, we have to take it positive because it was in the positive direction. Here only difference is you have to take minus. Rest all will remain same. Belt with respect to ground will not change because belt is not coming back. Belt is only in one direction. Only the child is coming back. That's why it is minus. That will give you minus 1.67. We put it here. That will give you answer. VCO will be I told you. Whenever they are in the opposite direction, they will always get minus. Okay. I'll stop here. Some more problems here and there from the question papers